Hey, good morning, everyone. So today I'm giving you guys the option of having a video so you can take a look at what's going on. We are still finding using implicit differentiation. We will be doing implicit differentiation to solve related rate problems, and now we're going to use some geometry formulas. So just remember that the dx dt is still our derivative. We've had that discussion. Just kind of warming you up. If this is my equation, could you find dy dt when x is 3 and that? Again, just kind of going over, you're taking the derivative with respect to dt. And that means whenever I take a derivative of a y, it becomes a 1. And that's dy dt. And it's going to equal, take the derivative of x squared, it becomes 2x, and that would have a dx dt behind it. And then there is another 3x, so subtract derivative of 3x is 3, and then it needs that dx dt behind it. Remember, we write all of these little fractions because it doesn't match that respect to time. So now it's just a matter of plugging it in. So my dy dt is going to equal 2, oh, there's an x, so plug in a 3, dx dt, plug in a 2, subtract 3, there's a dx dt, plug in a 2, and when we work that out, 2 times 3 is 6, times 2 is 12, subtract 6, my answer is 6. Okay, so just kind of warming you up. This time they want us to find dx dt when x is 1 and y is 5. So still using that same equation down here that we just did, I'm going to plug in 5 would equal 2 times 1. Oops, there's my dx dt. And it's going to subtract 3, and there's another dx dt. And now I got to get dx dt by itself. So if I look at this, I have 2 dx dt minus 3 dx dt. So I have the equation 5 equals negative 1 dx dt. And dt, excuse me. So dx dt is going to equal 5 divided by negative 1, or just negative 5. Okay, that was just a little warm-up, getting you thinking about this. So now, let's take a look at something like this. I have an equation. It's telling me to find the derivative when x is 2, and they told me here's my dx dt, and they want me to find dy dt. So the first thing I need to do is I need to take the derivative with respect to t. So dt. Okay, so what does that look like? Derivative of a y is 1 dy dt. Got it. Equals. Ew, this side here is a fraction. Guess what? Low d high minus high d low, square the bottom, and away we go. So low, 1 plus x squared. D high, oh, that's 0. Yay, subtract. High is 1. D low is 2x dx dt. Don't forget that. You took a derivative of a variable. And on the bottom, 1 plus x squared quantity squared. Now, somebody's going to say, Mrs. Kendall, you didn't put in a derivative, a dy or dx. I took a derivative of a 1. There was no variable on it, so that's fine. Now, some neat things happen. Do you see that anything times 0 is going to wipe that out? So I can keep moving on, and I can start to plug in, or I can look at what my formula is. My dy dt is going to equal 2x dx dt all over my 1 plus x squared quantity squared. And I have to apologize, this was negative, so that negative sign has to stay there too. Okay, so plug in my values. Dy dt is going to equal -2. Oh, the x value that they gave me was -2, and the dx dt they gave me was 2, all over 1 plus the x value they gave me was negative. Oops, don't know what happened there. The x value that they gave me, that looks pretty. The x value that they gave me was -2, just writing over that blob, and it's being squared, and then that whole quantity being squared. So mathematically, -2 times -2 is 4, times 2 is +8, and on the bottom, 1 plus -2 squared is 5, 5 squared is 25. That would be my dy dt. Okay, I think you guys are starting to get the hang of this stuff. So let's dive into the back side here, and we're going to practice working on those derivatives. And today it's the same thing. We've got to just figure out, ask yourself, what's the formula, differentiate it, substitute, and solve. Okay, I'm getting tired of green, so let's change colors. So, and air is being pumped into a spherical balloon. Okay, so now you need to think of all your formulas that go with that. At a rate of this, it has inches cubed in it. The cubed inches means volume, so that is my dV dt. Okay, so what is the rate of change of the radius? That means I'm looking for dr dt. That is what I need to find. Oh, my pen doesn't want to work real well this morning. And the radius is 2. So I need to know what volume formula is. Volume is going to equal 4/3 pi r cubed. Yeah, you got to memorize it. So I need to take that derivative with respect to t. Okay, so when I do that, I get dV dt equals the coefficients of 4/3 and the pi stay there. The variable is r, so 3r squared took its derivative, dr dt. And now it's just a matter of plugging in all the numbers you know. My dV dt is 4.5. It's going to equal 4/3 pi 3. My radius that they gave me is 2, and I'm going to square it, and my dr dt is what I'm trying to find, so I kept it dr dt. Now, some things that I'm hoping that you've seen. This 3 and this 3 cancel. So I'm left with 4.5 being divided by a 4, a pi, and 2 squared is another 4, and that's going to equal my dr dt. And when you work that out, it turns out to be 0.089. And this is a radius. What do we measure radii in? Inches. And it would be per minute. And that's my final answer. Okay, hopefully those are getting easier for you. So now, taking a look at the next one. All edges of a cube are expanding at a rate of 5 centimeters per minute. How fast is the volume changing? Oh, we got to remember volume. Volume equals side cubed. They specifically said a cube. That's what it would work. The rate at the sides, that would be a ds dt. dt, sorry about that. And how fast is the volume? And I'm looking for dV dt. That's what I want to find. So hopefully you guys are starting to scribble on this too. So what do I have to do to that formula? I have to take that formula with respect to t. So when I do that, I get dV dt equals derivative of s cubed is 3s squared ds dt. Okay, so fill in the numbers that you know. I don't know dV dt. That's what I'm trying to find. Equals 3 times my edge is 7 squared and my rate is 5. My dV dt, when I work that out, should be 735. Now, This is a volume, so it would be centimeters cubed per, and we were in minutes in this case. Okay, last one. So for this last problem, dirt is falling into a conical pile. Oh, a problem from yesterday at a rate of 7 feet cubed per minute. The diameter of the base is 5 times the height. At what rate is the height of the pile changing when the height is 12? Okay, so the 7 feet per minute cubed, dV dt. Got it. The diameter of the base is 5 times the height. So conical pile, oops, sorry, it doesn't look that much like a cone like that. The diameter, it says 5 times. Well, let's just make it a 5. That means the height would be 1. Do you notice that my radius would be 2.5 then? Because that's where my key comes in for a couple of things. So remember, my formula for a cone, volume equals 1/3 pi r squared h. I can't have r's. So remember, over here, this is what helps us. Our r compared to h would equal, my radius is 2.5 compared to 1. So 1r equals 2.5 h. Hey, I've got my conversion. So my new volume formula would actually be volume equals 1/3 pi. That radius is going to be replaced with my 2.5, or I'm going to put it in fraction form, 5/2 h. And the only reason I put it in fraction form because I don't have my calculator with me. I've been doing it mostly in my head, so I can take care of it, which means my volume would equal 1/3 pi 25 times over 4 h squared h, which gives me a final formula of v equals, I'm going to combine the fractions, 25 pi over 12, that made my coefficient, h cubed. Okay, so there's my formula in h. So now I need to take the derivative of that with respect to t. So I get my dV dt equals the 25 pi over 12, and now times 3h squared dh dt. See a little reducing that's going to go here. This and this make a 4. So we've got a little bit of something. I plug in all the numbers that they gave me. dV dt is 7 equals, I have 25 pi over 4 now. The h is 12, and that's going to be squared, and I'm after dh dt. So to get the dH dt by itself, I'm going to multiply each side by 4 divided by 25 pi 12 squared. That's what I'm going to multiply each side by. And when I do that, I end up with 7 times 4, all divided by 25 times pi times 12 squared equals my dH dt. So I can grab my calculator, 0.002 feet. This is a height. Height is measured in feet, and that would be per minute. So that is how fast the height is changing every minute that the dirt's falling onto the pile. Good luck tonight, and we're going to keep working on those cone problems too.